Hello, this is Mr. Wynn, and today's video is about multiplying and dividing rational expressions. I'll start off by saying that a ratio is just a fraction. This lesson will involve multiplying, dividing, and simplifying fractions, but with variables or letters in them. The good news is that it follows all the same rules and steps of regular fractions, but the bad news is that since they have variables, you can't use the calculator to do math or reduce it for you. So let's review the basics. When you're simplifying or reducing a fraction, you divide the top and bottom by the GCF. So if I gave you 10 divided by 20, you're supposed to figure out that you can divide the top and bottom by 10. So that gives me 1 over 2. Now that is correct, but when there are variables involved, it's going to be less obvious. So we're going to do this the full, complete way. So we're going to divide by the GCF. So GCF stands for greatest common factor, and the keyword there is factor. So it involves factoring or breaking down. So this is basically tree branch stuff, finding the primes but without the root part. So this was the old way, the shortcut way, which works. But now let's do it the full way. So, alright, if you have 10 divided by 20, you're going to break down 10, you're going to break down 20. Well, 10 is just 2 times 5. 20 is 2 times 2 times 5. Find the primes. Now we're going to cross out the repeats, the common factors, the GCFs. So 2 and 2 cross out. 5 and 5 cross out. Now there's something left on top. It's just a 1 because that's 1 times that. So my final answer is 1/2. That's the way we're going to be doing this. We're going to break things down, factor them, cross out the repeats. Whatever's left over is our answer. All right, so same answer. So here's the first one. So step 1 is to always factor. We don't ever have to distribute, multiply, or FOIL. The 3 ways we'll use factoring are GCF, the ACX method, and difference of squares. And in general, all of our quadratic factors can break down. If you don't like the ACX method or difference of squares, you may use quadratic formula to get the roots, but then you have to change those roots into factors by changing the sign, but that takes a long time. So let me refresh you on the ACX method. So let me factor that top part. X squared plus 4x plus 3. If I do the ACX method, right, A times C goes on top. So A is 1, C is 3. So it's positive 3 on top. B goes on bottom. So here's AC, here's B. You're going to figure out, and these are both positive. We're going to figure out what multiplies, well, 2 factors, numbers multiply to AC. So multiply to 3, but add to 4. Well, I know that positive 3 times positive 1 gives me positive 3, and 3 plus 1 gives me 4. So I'm going to use those as my factors. It's going to be x, you just keep that sign the same, x plus 3, and x plus 1. If I FOIL that or distribute that, I get x squared plus 4x plus 3 back. So let me fix that top part. So the top part, that says it's 5x, but that next parentheses changes to x plus 3 and x plus 1. So my top is fully factored. Again, that quadratic part, x squared plus 4x plus 3, factored into x plus 1, x plus 3. Now the bottom, x plus 6 is already factored. Just leave it alone, it's already linear. But x squared minus 9. Again, you could do the ACX method, but x squared minus 9 is a difference of squares. Remember, if it's a difference of squares, just square root both of them. And make 2 parentheses. Square root of x squared is x, x and x. Square root of 9 is 3 and 3. But the minus has a plus and minus. If you FOILed that or distributed, you would get x squared minus 9 back. So that is going to replace the x squared minus 9 in the problem. So it's going to be x plus 3, x minus 3. So we're done factoring. That's the first part. Alright, I'm going to erase this bottom part because I need some space. So now we're at fully factored form, and before we reduce, before you cross out the repeats, we need to find our restrictions. Remember, we cannot divide by 0, so we have to make sure the denominator isn't 0. Just set each factor of the denominator equal to 0 and solve it. And this is actually an application of the zero product property, where if you have multiple things being multiplied to equal 0, at least one of those things has to be 0. One of those factors has to be 0. So just my denominator, x minus 6, x plus 3, x minus 3. If that equals 0, one of the things has to multiply 0, because 0 times anything is 0. So it's the first one, x minus 6 equals 0. I just change the sign, x equals 6. The second one, I'm just going to change the sign, x equals -3. Third one, I'm just change the sign, x equals +3. So those are my restrictions. X cannot be those. If you use one of those three numbers in your answer, your bottom denominator will turn into 0, and you can't divide by 0. You get an error. All right, now that we found our restrictions, just cross out the common factors, the GCFs, and we're done. So it says x plus 3, x plus 3 are the same. And is there anything else? Nope. So our final answer is 5x, x plus 1 on top, over x minus 6, x minus 3 on bottom, where so restrictions are x cannot equal 6, -3, or 3. That is the answer. All right, next problem. Sometimes you have to factor out a -1 to change some signs. So here's the next one. Again, we always factor GCF first. So that first parentheses has a W in both. So I'm going to change this to W times 4W minus 3Y, W plus Y over 3Y minus 4W, 5W plus 4. This is fully factored form. We should find what we can't have. So remember, the denominator set them equals 0, just each factor. If I did this, I would solve for y. I'd add 4w both sides, divide by 3. So y cannot equal 4w over 3. Sorry. Other one as well. See, 5w plus y cannot equal 0. If I subtract 5w, that's it. So those are my two restrictions. Y can't be those two things. Now, there's nothing that cancels out. But you see that second parentheses, this thing right here has has 4w and 3y. This down here has 4w, 3y, but the signs are different. So if the signs are different, you take out a -1 from either one. I'll take out from the top. So if I factor out a -1 in that first parentheses, it'll become -4w plus 3y. This is w plus y. The bottom stays exactly the same. All right, well, you could rearrange the order. You make it +3y minus 4w, but now we can cancel this. And that should be it. So whatever's left is our final answer. I'm going to say it's -w, because -1 times w is -w, times w plus y, divided by 5y plus w, 5w plus y. Our restrictions is where y cannot equal 4w over 3 or -5w. All right, so that's my reduced fraction with the restrictions. All right, next one. When you multiply fractions, you multiply the top by the top and the bottom by the bottom. For example, if we did this, 3 times 7 is 21, 4 times 6 is 24. We have to reduce that. So if I divide the top and bottom by, say, is 3 the best? 3 and 3. See, I get 7 on top, 8 on bottom. All right, now again, that was the old way because we knew we could just divide by 3. We should do it the new way, just like I did before. So that was old. Here's the full or complete way. If you have this, you're going to find the factors again. So 3 is just 3, that's easy. Times 7, nothing there. 4 is just 2 times 2. And 6 is 2 times 3. Alright, so I factored everything, and remember, I just put them together. You can combine to a single fraction by adding and multiplying. So, cross out the repeats. Well, 3's cancel. All I have left is 7 on top, 2 times 2 times 2 on bottom, which is 8. There's no need to reduce here. So if you do the full way, you cancel out the GCFs, you won't have a bigger number to reduce. It's just straight to the answer. All right, so simplify this. Well, first is factoring. If I do the ACX method for the top one, I get it turned into, let's see, 8 and 2 can make 16. It has to be a negative 8 and a positive 2. All right, so if you FOILed that, it'd be x squared plus 2x minus 8x, so it gives me negative 6x, and negative 8 times positive 2 is negative 16. If I factor the bottom, that gives me x minus 8 times x minus 8. You could just write x minus 8 squared, but I'll leave it like that. For this other side, x minus 8 put in parentheses, and down there, let's see, 2 and 3 can make 5. So 2 and 3, positives for both. All right, now before I cross out, I define my restrictions. Set the whole bottom equals 0, find what x cannot be. So I already know that x can't be positive 8, can't be positive 8, that's a repeat. Can't be negative 2, can't be negative 3. So right here, I just change the sign, but it's a repeat, change that sign, change that sign. All right, so once we're on the restrictions, cancel out the cost of the repeats, the common factors, and we're done. You see x minus 8 here, x minus 8 there. X plus 2 here, x plus 2 there. X minus 8 here, x minus 8 there. So on top is a single 1, on bottom is x plus 3. So my final answer is 1 divided by x plus 3, where x cannot equal 8, negative 2, and negative 3. All right. Last review is when dividing fractions, you just multiply by the reciprocal, meaning you flip the second fraction and then just do regular multiplication. So 4 divided by 7, so the fraction 4/7 divided by 4/3 is really the same thing as 4 over 7 times 3 over 4. And just do the correct way, we'll factor them down, 2 and 2, 3 on top, 7 times 2 and 2. Well, Carson repeats 2 and 2, 2 and 2. All that's left is 3 over 7. So if you check that in calculator, you would get that. Same idea here. So this is a repeat of what we just did. So first, let's rewrite this as a multiplication problem. It's x squared minus 16 over 12y plus 36 times, not divide, we don't like dividing fractions, y squared minus 3y minus 18 on top, x squared minus 12x plus 32 on bottom. Now we do what we've been doing. Let's factor them. The top left one is a difference of squares. That is x plus 4 times x minus 4. This bottom, I could factor out GCF of 12. What's left is y plus 3. On this other one, let's see, if I do the ACX method, I can use 6 and 3, because 6 and 3 multiply 18, and if you subtract me, get 3. So y minus 6, y plus 3. Because they multiply for negative 18, they add for negative 3. On the bottom, ACX method, 8 and 4 can make 32 and 12. So negative 8, negative 4. Now before we cross out, gotta find our restrictions. Set the bottom equal to 0. So if I change this sign, y cannot be negative 3. Change this, x cannot be 8. X cannot be positive 4. Now be careful here. Since it was a fraction before division, this also used to be a denominator, so we got to check that as well. So some teachers will do this. They'll make that weird shoe-like thing. You have to find the restrictions for all three of those. So y also cannot be positive 6 from this, and negative 3, which is a repeat. All right, so there's 4 restrictions here. All right, finally, cross out the repeats. So y plus 3, x minus 4, x minus 4, and that's it. My final answer is the top part is x plus 4, y minus 6. Bottom part is 12 parentheses x minus 8. And the restrictions are where y cannot be negative 3 or 6, x cannot be 8 or 4, and that is it. Alright, so that's how you multiply and divide fractions and reduce by factoring. Here's your practice problem. Try it, gets the answer. If you can do that, you should be fine for class. Again, this is Mr. Wynn. Thanks for watching. See you later. Bye.